Up until now, I've been talking about how C# is an object-oriented language, and you've been seeing me use objects throughout some of the previous examples. And we've reached the point now in the course where we actually need to learn how to define and use our own objects in C#. If you're going to be a C# programmer, there's no getting around the object-orientedness of the language, and now is as good a time as any to take a look at how to get started with object orientation in C#. So as I've mentioned many times, C# is, of course, an inherently object-oriented language. There's no getting around this. And in fact, everything that we've been doing up until now has involved objects in one way or another. The variables that we've been defining, those are objects, those integers and strings and everything else. We've been using the console object to write output to the console window. And even the program itself that we've been using is itself an object. So objects are everywhere in C#. Your programs will not be any different. Programs are basically collections of objects. So objects contain data, and they contain the logic that operates on that data. It's a way of keeping related data and logic in the same place. And of course, objects can communicate with each other, because if they didn't communicate with each other, not a whole lot of useful work would get done. And of course, not only do the objects communicate with each other, they communicate with the program that hosts them, because the program itself is an object, and this is how your programs communicate with the .NET framework as well. In C#, there are three main terms you're going to have to keep track of. There's class, there's interface, and there's object. Interface is a little bit advanced, so we're not going to focus on that right now. We're just going to focus on the class and object terms for the remainder of this section, and we'll see a little bit about interfaces later on. Classes in C# are one of the most common types that you will come across, and a class essentially provides a blueprint or a description of what an object looks like and what it does. The blueprint, or description if you will, defines things like what kinds of data that an object of a certain type holds, and it also defines what kinds of things that an object can do. It's important to keep in mind, however, that a class is just a definition. It's a description. It's not the actual object itself. For example, when you have a blueprint of a house, the blueprint you can think of as being a class, but it's not the actual house. When you build the actual house, that's the object. The blueprint just provides a description of how to do that. In your C# programs, you will usually define your own classes to do whatever custom work you need to get done, as well as using the classes that are provided by the .NET framework. The .NET framework is pretty full-featured. It provides hundreds of classes for doing all different kinds of things, and you'll take advantage of these classes as you build your own applications. For example, suppose we were building an application that managed a list of to-do items. You can imagine that we would have a class to handle to-do items. We would probably have another class to group all of those to-do items in a to-do list. And these are classes that your program would define. But there's a whole bunch of other classes that the .NET framework would provide for you. Things like dates and times and array lists and classes for working with strings and communicating with the internet. These are all provided by the .NET framework. And as you build your applications and learn more about C# and .NET, you will use more and more of the .NET classes to round out your application's functionality. So what do classes define? Classes essentially define two major things, and these are called members. The first set of things is fields and properties. The second set of things are methods or functions. Now, functions and methods are pretty much the same thing, but the word method is what's commonly used in object-oriented terminology, so that's what I'm going to use here. The fields and properties are the kinds of data that the object holds and works with. The methods are what the object can do. This is their logic, the functionality that contains in the object. Again, if you go back to our to-do list item example, you can imagine that a to-do item might have a name and a description and a priority and something like a due date, and then we would need to have methods to operate on that data. For example, setting the description and changing the priority and marking items complete. These are what classes define, and as you build your own classes, you will define your own fields and properties, and you'll write your own methods to work on those pieces of data. Classes can also inherit attributes and methods from other classes, and this is a very important concept in object-oriented programming, so it's important that you understand this. For example, let's imagine that I have a class that I want to define called Class A, and Class A contains a couple of fields like name and age, and it has a function in it. In this case, it's called say hello. Now, you've probably already seen examples like this, and in C#, you would refer to these fields and functions by using the dot notation. So you say a.name and a.age for the fields, and a.sayhello to call the method. I can also define a class that inherits from class A. And in object-oriented terminology, this is called creating a subclass. So if I wanted to create a class B that inherits from class A, I would define class B, put a colon after its name, and then put the name of the class that the class inherits from. So here you can see that class B with a colon and then A means this is class B and it inherits from class A. And in class B, I've defined a couple of things. I've got another property called address and a function called say goodbye. So again, you would refer to these using standard dot notation for the class B, like b.address and b.saygoodbye. But because class B inherits from class A, it also has all of the fields and properties that class A has. So class B also has a say hello function and a name property, even though I haven't defined it in class B. It just gets all of those things because it inherits from class A. So in object-oriented terminology, we say that class B is a subclass of class A, and class A is class B's superclass. You'll see these terms used throughout object-oriented documentation. Whenever you read documentation on the web, especially on MSDN, you'll see terms like that. You can think of C# objects as being a kind of stamping machine. So classes, as I mentioned earlier, are used to create individual objects. And each object that is created from a class is called an instance. So you can think of this as some kind of machine that stamps out physical parts. Suppose I had a class definition called person, and the person class had the name and age and the say hello function. Each time I made an object, that's called creating an instance of class person. So here I've got 3 instances of the person class. I've got person A, B, and C. And each one of these real objects has actual data that's filling out the class. So we're using the class definition or the blueprint to actually make instances of that class. So why would you use classes and objects? Well, using classes and objects, especially in C#, which is an object-oriented language, really makes it easier to maintain and build applications. First, it helps abstract ideas away from a specific implementation, which allows you to focus on the core parts of the program. Since the .NET framework provides a whole bunch of classes that cover common areas of functionality that you don't have to write yourself, you can focus on building the specific parts of your program that are only pertinent to your business logic. You can then reuse all the classes that .NET provides for you, which really makes developing your applications a lot faster and a lot easier. Using classes and objects also helps encapsulate the program's functionality into understandable pieces, because each object has its related data and logic all kept in one place. To go back to our to-do list item example, each to-do item would have not only the information about that particular to-do item, but the logic that operates on it. So you wouldn't have different pieces of logic scattered all over the place in different locations without knowing where each one is. It just makes it easier to understand the way that an application works. It also helps organize a program into natural parts that can be easily extended, and this is sometimes referred to in the object-oriented world as factoring. Once you've factored your application into its natural parts, the object itself and the program comes to mirror real-world constructs and ideas. Again, taking a page from our to-do list example from earlier, when you make objects that mirror real-world constructs like a to-do item and a to-do list and so on, that makes the program a lot easier to understand and go back in and maintain years later. So using classes and objects is a really fast and easy way to build applications that you can maintain in the future and other people can work on as well and get up to speed on quickly. So we've reached the point now where we've completed our refresher into the world of object-oriented programming, and we're going to spend the rest of this section seeing how to define classes in C# and build our own object-oriented programs in .NET and C#.